All right. So hello, everyone. Good morning, good afternoon, good evening from wherever you're joining us from. We're very happy to have you here today. My name is Dalia. I work as a community manager at Kong. Welcome to October's Tech Talk. Today, we have Aaron from Salt Security. I will let him introduce himself. The topic for today will be adaptive API security. I know this topic is very hot nowadays, so we're very at the end. You will see there is a Q&A function at the bottom, so please use it to input all of your questions there, and we will answer it when he's done presenting. And I think that's all. Aaron, please take it away from here.
Thank you so much, Dalia. So hi, everybody. Aaron Miller. I'm a sales engineer here at Salt. And actually, before I was at Salt, I was at Kong. So I don't know if some of you have been with Kong for a while. Maybe you remember me, but really enjoy the product. Always gives me a little happy, happiness inside when I come across a prospect that's using Kong. That comes out pretty frequently. Now, one of the things that's top of mind, or should be, whenever you expose APIs is how are you going to secure them? And it tends to not be front of mind, at least as much as it should be, given the risks. And one of the things I think that's useful to think about is, like, relative to biological systems, APIs and computers are very, very new. But APIs themselves are old as far as computer systems are concerned. So I was thinking of like drawing this correlation between biology and digital systems. And I think it's kind of fertile ground for discussion. But the very first thing that's going to come up is why, right? I mean, like, biological systems are completely different than digital systems. It's not like I'm going to take something in biology and directly apply it to a computing system. They're very, 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 very different. So what could we really learn that's going to apply? I think with that point of view, yes, right, it doesn't really apply, and you'll get this kind of skeptical look from maybe some of your colleagues, or I always think of this as like a doubting, kind of mom look. But if we take the point of view of thinking about like a corporation, I assume most of us work at large groups. You can think of a corporation as a body, right? And it's under constant threat of attack from external sources. And draw the analogy to an organism that has faced life and death situations literally by having to evolve over millions of years. I think we can learn something from the approaches that have been taken by living systems, and see, if we can apply some of that architecture to our digital systems. So that's what we're going to be talking about today. And definitely, if you have questions, bring them up. I'm not going to address them immediately, but we'll get to them towards the end of the talk. So, speaking of community, if you go out to Wikipedia like I did, you'll find that there's two large kind of groups of different styles of immunity. The very first one, the innate immunity, is the oldest, and it's the system we have built into ourselves. And then the more newly evolved one, apparently that only shows up in jawed vertebrates, is the adaptive immunity, kind of the learning component. So just to get some of the analogies out of the way, let's talk about this, right? So the innate immune system, you can think of as like a WAF, right? Its primary job is to distinguish the external from the internal, right? So like our skin, right, is a barrier, like a firewall. It knows what is outside the skin, and obviously what is inside your body. It forms that difference. Inside of our body, there are actually cell walls, again, that define the outside of the cell wall and the inside environment. In our digital systems, you have a WAF, you have a firewall, you have outside the company, and you have inside the company. You probably have to VPN in, or present some credentials to show yourself that you're an employee of the company versus, a business partner or something like that. A lot of times APIs have the same concept, right? So that's kind of like your primary form of defense. So again, think of innate immunity as your WAF, right? And obviously you can't survive without that. So it's a valuable thing. Now, in contrast to that, is our learning system, our ability to adapt, right? Because innate is great, it's fast, but it doesn't really learn very well. And our adaptive immunity system, that's what we're going to be talking about here, is adaptive immunity as applied to API security. Because it's helps solve the problem of what if, something gets through your external defenses, and on top of that, has actually formed the ability to change, right? So think of, our friend COVID-19, right? It was not seen before, compromised a lot of immune systems, and it forced us to come up with solutions to address that type of issue, right? Now we're going to get into, how this adaptive system works, but we're going to take a little detour first. And I think this helps describe it in a slightly different way. And that is the other part of our body that actually learns in this way relates to actually how we smell. And if you think about it, it's like we can actually smell compounds that we synthesize in a lab that have never shown up before. And if you ask yourself, well, how can we do that, right? How can we actually recognize something that has never, been present in evolution before? And this actually helps us answer the same problem from an attacker point of view. How can we protect ourselves from, business logic attacks that have never seen the light of day before? And the way it works in smell, at least according to the latest theories, is it's kind of a fit model, right? So you'll notice that each of these color-coded and shape-coded pieces fit into different parts of our nose slightly differently. And the way it fits determines what our brains interpret as the smell of that particular molecule, right? So we generate a lot of these different shapes in our nose. We don't know exactly what we're going to smell, but the molecule that comes in fits in a certain way. And then that sends certain signals to our brain telling us that, oh, okay, this smells like a flower, or this smells like a spice, right? All of those types of things result in the recognition and the ability of our body to adapt and learn what these are like. Now, if you remember, like you'll have certain scents that are triggered when you smell them that bring back like a flood of memories, right? It's a very strong sensation. So this relationship between smell and memory is actually also part of our immune system. We can actually remember attacks that we've faced from the past and use those defenses again. So, and that's critical to mounting an immune response. Once we've mounted it once, it pays off again. It's the basis of vaccination. Same idea. Okay. Now, this is great to have this ability to recognize threats, even though they've gone into your firewall. But what if you start recognizing your own body, your own manufactured compounds inside your body as a threat? That would be terrible. That would be autoimmunity. And one analogy you can think of is, like a false positive in our work, right? It looks like a threat, but you realize it's actually non-threatening traffic that just looks a little bit different. So this whole mechanism of recognizing self from non-self inside the body is very, very critical. And the way our own bodies approach it is during the first part of our lives, we're actually, as toddlers and even younger as infants, we're exposed to a lot of new compounds, and our bodies are kind of just learning what is in the body and self and non-self. But if you don't get exposed to enough, you kind of that window closes, and you start then later in life mounting defenses against innocuous non-self compounds. So, for example, those of you that have allergies, it's not something that's going to kill you, a pollen, but it wasn't recognized early enough in your body as being a harmful or not harmful compound. So you then mount an immune response against it, right? You get a runny nose, all of those kind of typical initial immune responses you'll get. And those are not, beneficial to the organism, just like a false positive, right? It's not beneficial to your company to chase down that type of issue. So you need this kind of ability to learn what good looks like, so that when an actual threat comes along, you can mount a response to it, right? So I drew this analogy earlier about allergies being like false positives, autoimmune responses, right, where you're attacking yourself. Basically, think of this as like wasting resources inside of your company, and asking your developers to chase down and fix things that don't really need fixing. Again, a huge waste of resources. And likewise, if you're not picking up the actual attack, right, a false negative, then you've got a major breach on your hands. And maybe it's to the tune of many millions of dollars, a lost reputation. You have big problems to solve. So there's consequences to not being able to accurately determine an attack from a non-attack. And let's get into like what this might look like, and how where I work helps solve this type of problem. Right? So number one, you have to have the ability to pick up anomalies in the traffic. And at the scale that APIs typically operate at, right, up here with 100 million API calls with 1 million different users, we're not going to be able to do this manually, right? We have to leverage systems to do it. So the very first layer of defense is figuring out if it looks like your existing traffic, right? Do the requests and do the responses kind of match what you've seen before? That's great. You can find anomalies in that traffic, but if you kind of end there, and a lot of the companies in the space kind of leave it there, right? Anomalies are deemed as good enough, but I'm here to tell you that it's actually not. I mean, like, Salt is the OG API security provider, and we've got the patent to prove it, meaning that we've seen the most volume of API security attacks. And with an AI ML solution, it's all comes down to how much data you've seen and the quality of that data. So by being the first mover in the space, we have more of that than our competition. And we actually layer in another neural network, right? And this allows us to filter out from the anomalous traffic the truly malicious traffic, right? Where the intent of the user generating that anomalous traffic was actually malicious. And that is, I think, what distinguishes Salt from the competition. We really pride ourselves in this ability to do runtime protection, right? So, if you've been to a security conference like I have, like RSA or Black Hat, I mean, there's thousands of different vendors, right? And they all have their own kind of unique take on this. And our unique take is runtime protection, the ability to protect you from the unknown without flooding you with false positives. That's the significant challenge that we all face in the security space. Clearly, there's lots of room for different approaches And Salt won't be the only solution that you deploy to defend your systems. But in that one narrow space of protecting you against unknown, novel business logic attacks, I think you'll find that Salt is the leader in that space. Okay, let's move on. And we're going to talk next about why it's so important to learn. And we're actually zipping along pretty good on time. So happy with this. Maybe we can return some time back to you. The ability to learn is critical to a security system, right? If it can't continuously learn what attacks look like, when you're faced with something that hasn't been seen before, it just won't know what to do, right? And it's this fine line that we're walking. We don't want to mount a response against something that is different just because it's different. We want to kind of say, is it different and malicious? And that's the challenge that we face. Let's talk a little bit about what this looks like and why this is a challenge, right? So, okay, your developers are all focused on creating new features, right? That's what's going to distinguish you from your competitors and get you to land new customers, right? Is something that is never been advertised before. Like if you're a bank and you give somebody the ability to deposit checks with their mobile phone, great. That's a great new feature to have. But the one thing that you always want to have in the back of your mind is like, can somebody take that and use it in a way that I never intended? And I don't think there's a way actually to 100% protect us from somebody taking what we have worked so hard to build and use it for their own purposes that I never intended. I think that risk is always going to be there. So you have to have something that listens for it. But rather than talk in the abstract, I'm going to talk about a very specific use case that happened a few years ago at Uber, right? So the issue is that valuable piece of information, the UUID that was unintentionally posted in a response, and you could take that key and use it against other APIs, and especially a sensitive API that gave back all the information about the particular UUID that included everything, right? The address, the registration of the driver, all of this information was in that payload. And Uber had authentication. That was not the problem. The problem is in the authorization phase, the object could be actually used in another API endpoint to return information that shouldn't have been returned, right? So it's broken authorization really was the root of this. Now there's the OWASP, which you might know for the web top 10. There's actually a branch of this is the OWASP API top 10. And this falls under the API, OWASP API #1, broken object level authorization. A lot of people shorten it to BOLA. So you'll see that out there. And it used to be known as IDOR, right? So if you go Googling around for either one of those acronyms, you'll see a lot of discussion about this. And let's talk a little bit about what this looked like from an API point of view, right? Since we're here talking about COM and how would we kind of learn about this and how would a system such as Salt or another API security provider protect you from this? Well, the way this exploit happened was up there at the top, right? You submit a request. You somehow learn the person's phone number, let's say, and you could submit that phone number, make an innocent request, and it's just kind of like a blind attempt to call this API. And the problem with the exploit was that it would return the UUID for that phone number. Even though it's not a successful API call, in the error message back, you would reply with that. Now, I can see as a developer, and you throw an error, oh, great, that UUID helps me kind of fix, the other APIs. But if you don't think like an attacker, like a lot of developers don't, and realistically can't, developers can't be development experts and security experts, right? They're two kind of separate disciplines. Then you run into this problem of exposing that authorization issue and allowing that object ID, that UUID, to be used against a different API. And then that API will now return the full payload of what that driver's credentials are. And that really forms the core of this particular exploit. Now, this is very specific to a particular vendor and a particular API. So no doubt the APIs that your companies have won't be vulnerable to this type of exploit, but they will be vulnerable to other types of business logic exploits that none of us have really thought about, right? But this is what attackers do, right? They think about how to break things, not how to build things. And it's just almost like a different mindset. It's unfortunate, but it's a reality we all have to deal with. And so, how do we kind of protect ourselves from this? Well, we're getting near the end here. And really, I want you to walk away with some of the basics, right? You have this idea of biological systems have innate immunity, and you get that in a digital system with a WAF, right? Distinguishing the outside from the inside. But the whole purpose of this talk was to introduce this idea of a learning system, right? A system that remembers attacks of the past and has the ability to distinguish self from non-self, even after it's gotten past your WAF, even after it's gotten through authentication and as a check on your authorization, right? And that is what Salt is here to offer, as well as some of our competition. And the reason why we're here presenting is because there's actually a super handy, great Kong plugin that leverages both Kong Community and Kong Enterprise, and basically sends that payload out to Salt, where we do our magic and learn your API traffic, and then learn what attacks might look like against that same traffic. Okay. So we're now moving into the questions phase of this. I'm going to open up the chat here. I see a couple things are in here. Let's take a look. Okay.
Thank you very much, Aaron. That was awesome.
Yeah.
Very informative. I love it. Let's see if anyone has any questions. Now is your time, guys. Don't be shy. Ask away. Let's see. Or maybe it was so informative that there are no more questions.
That happens sometimes.
Yeah. All right, we'll give it like a minute.
Yeah. I saw some people joining from Massachusetts. Welcome. I wonder if it started. It just hasn't started snowing out that way, has it?
No, probably November or something. Oh, there's one question.
Security.
I'm guessing that would be the docs page. Let's see.
Yep.
And there's one in the Q&A while I research the docs.
I'll answer that. I'll type that. Oh, actually, so Bola. Yeah, so let's take a look actually in our demo environment. So this assumes we've recognized the API traffic coming in and learned what the APIs look like. And then when Ebola comes in, it'll look something like this, right? So there's actually couple different flavors of Ebola. Single ID Ebola, like you see here. This one is a credential stuffing style of Ebola, right? So somebody is basically sent in a lot of traffic um, way outside the normal bounds of somebody submitting a different account ID. And this salt is alerting you to that error condition, right? So it shouldn't be something that should really happen. And you have early recognition of that. Now, if they get farther, like this one, and this is a double ID Ebola where they're authenticating as this user, but they're actually retrieving the data for a completely different user. This is a very serious problem. And the reason why your WAF won't see this as an attack is because nothing in the traffic is there to indicate, right, that this is an attack. But Salt picks it up because we're actually able to compare history and tell you that this is not normal traffic, right? And in this particular type of exploit, it shows up as an attack. Okay. Not clear what actionable insight I would take away from this. So WASP API. Okay. For hiring as well. Adaptive. So I'm saying that adaptive security practices are kind of the bread and butter of any of the API security providers, right? And the concern there is that you have a solution that protects you from that style of attack, right? Business logic abuse, that you have to have something that picks up not just abnormal traffic, but malicious traffic, right? So that's the difference here. Good questions. Thank you for those. Glad to know people are out there listening. What else is on people's minds?
Yeah, two more in the Q&A.
Great. So yeah, my best source for initial documentation for you, Krishna, is to go out to salt.security and have a look around, and then we can tell you a lot more about what this might look like. How to get a trial again, get a demo, tell us what use cases you have, and then we can go into a POV, right? We don't offer free trials right now. So, that's the best way to do it. What other security threats? So anything in the OWASP API top 10, right? Plus abnormal responses, abnormal requests. So good question there. How to practice hands-on and get business logic and API security and leverage systems and exploitation. Yeah, so the way to get practice with this is kind of, get set up with, some sort of API security solution. I recommend, I've taken some, API security classes. They typically tend to use a tool called Burp Suite. You're probably familiar with that, which allows you to kind of analyze the traffic coming in. You can modify certain parameters and see what responses you get from the API in that. And in that, you're going to learn a lot about the APIs that you're monitoring and how to possibly exploit that. The other thing I'd recommend is I learned about this tool, GitHub and Bambi. I really like this one, right? Because this is a way to kind of see what a bowl looks like. I liked it so much I actually contributed a little bit to the project. But this will kind of like walk you, through what a bowl looks like, how I can authenticate as one user, but retrieve the data of a different user. And it's nice because it has a couple different modes, right? It's got a vulnerable mode and it's got a secure mode, so that you can kind of see what should happen and what should not happen. Even though you're using authentication, you can actually still retrieve the data that you shouldn't be able to retrieve because of certain vulnerabilities. And there's other projects like this, right, out there. This is just one of them. There's another one literally called Crappy, kind of completely ridiculous API. I also recommend that one. That's a good one. And there's some others that are out there. But these are some tools that we definitely use as we talk to people about, how to kind of learn more about security. Definitely can recommend both Crappy and Bambi. So there was a question about implementing Salt in Postman. You wouldn't really implement it in Postman. You would have a way to implement a mirror of the traffic, and we don't have Postman as a source, but whatever it is, right? You would spin up a way. Say you spin up a Docker container, right? Say you spin up Kong, right? And you have then the Salt plugin inside of Kong, and then that would send the traffic out to Salt for analysis, so that we could then learn the traffic here and then protect you from attacks against it. Share resources link for API security solution. And I'm not sure what hands-on means. Hands-on, okay, got it. Yeah, so basically, I would say, like, go out to Kong, browse the plugin hub for the information there, and you can see not just Salt, but there's other solutions out there that map into the security space, right? So things like our friends from Imperva. Imperva is classically a WAF. They do have some kind of rudimentary API security, as well as who else is out here. WallArm, I think, is in here as well. So you can definitely learn from them. I don't believe there's any other security providers. There used to be one that we used to run into was No Name. It's possible they're in here. Let me see. No, not right now. As well as I hear great things about Traceable. So any one of those. How easy it's to integrate with Kong? Does it plugin support? Yes. So Salt supports both community and Kong Enterprise, right? In fact, I just pushed this PR yesterday, in fact, to update these versions. So those are hot off the press. All right. A lot of great questions.
All right. Let's see if we have any last questions before we end.
Yeah.
No. All right.
Inquisitive group, so that's always good. Yeah.
Thank you so much for answering all the questions, for the great presentation. We'd love to have you again sometime here. And to everyone who joined us, thank you so much. We'll see you again at our Tech Talk next month. We have another user call coming on 25th of October this month, actually. So let me send you the link if you all want to join us. I'll put it here in the chat. There you go. All right. So with that, thank you so much. Have a good day, good evening, and I'll see you soon. Bye-bye.
Thank you, darling. Take care, everybody. Bye-bye. Thank you.